Well, well, hello there. It's me, your favorite math teacher, at least from this year. We've got something to talk about today. Something that I'm going to appreciate. Maybe you might appreciate. Some of us are going off to college next year, going out into the world, learning new things. Here's the deal. It's expensive. There's no way that anything in high school could prepare you for what you're about to encounter. Some of us are going off to school. You've got student loans, FAFSA, all that borrowing, all that figuring things out. Now, just thinking, let's say we go to UConn or someplace else and we've got to take out some loans. You're going to have to pay those back someday. How are you going to do that? Can you afford to do it? Is your college education even worth it? Now, let's say, just throwing out some numbers there, you've got a school or you're going to be taking about $30,000 in loans per year. You go to school for 4 years, some of you 5, 6, 7. Let's just say you go to school for 4 years, $30,000 in loans per year. That's $120,000 that you need to pay back. Now, I am assuming that we are not getting grants or we're not giving forgiveness or anything else. I admit that. $120,000. You're going to make 40 grand if you're lucky when you get out. But here's the thing. Your favorite math teacher has you covered. I will pay for your school. That's right. Now let's go through a little bit of logistics here. So I'm going to switch over so we can take a look through some things. But let's talk about student loans here. Your student loans, I'm going to cover for it. That's me. I got it. Good old Tom has got you covered. Now, I'm going to have to cover this back though, because I'm going to be dipping into my reserves. I'm going to be taking money out of my funds. I'm going to expect a little bit of interest here. Instead of 5%, I'm going to lower this down to 4% just to be a little bit nicer for you. But 30 grand a year, 4 years, $120,000. Now, I'm not going to just have $120,000 because if I let that to you right now, I'm going to end up losing money long term. So I'm going to have to charge you a little bit of interest. I'll be even so nice, you don't have to pay me back. I know it's going to be tough the first year out, first few years out. You're going to want to buy some things. You're going to go, ooh, I've got a paycheck. Families, whatever else. You can wait 30 years till you can pay me back. But how much are you going to owe me? Now here's the thing. Compound interest. This month, a little bit of interest. So $120,000, maybe next month if you were to pay me back, you'd be $120,080. But then it's going to get a percentage on that for the next 30 years. Now, compound interest, let's say that I'm going to charge you that 4%. It's $120,000, 4% compounded monthly for 30 years. So don't worry about it. 30 years, you actually owe me $397,000. This is the magic of compound interest. So just to see that done out, $120,000, 4% interest for 30 years. You owe me almost $400,000. Now, you're not actually going to wait 30 years to pay me back. That's the thing here. You're not going to wait 30 years to pay me back. What if instead we make monthly payments? So a little bit this month, a little bit next month, a little bit next month for the next 30 years. We are not going to take that $397,619.76 and divide it by 30 years divided by 12 because you are going to pay me a little bit back next month. What happens is that $120,000 isn't building interest for the full 30 years. You're going to pay a little bit back. So you'll cover the interest for the first month and whittle down the principal. Next month, you're going to cover the interest that builds up and pay a little bit of the principal. And we're going to repeat that. That sounds a lot. Oops, forgot a little bit. Yeah, that's right. I'm coming for you. You owe me my money. All right, back into this. If we made monthly payments, this gets into our systematic savings. Now what's going to happen is, okay, well, the full amount that you owe me, that's my $397,000. Well, can we solve for that D value? Can we solve for that deposit amount? How much you were going to put aside each time? Well, here we've got $397,619.76. You don't know how much you're going to pay me every month. 4% interest. We're going to do that monthly for 30 years. I can substitute this in. Rather than wait 30 years, I can solve for the D value. So I'm going to cross multiply by that 0.04 over 12. I'm going to divide by that bit. I can solve for D. Let's put this into the calculator. So that is 397 12 divided by parentheses around everything. Okay. Rather than paying me, waiting 30 years and paying me almost $400,000, instead, you're going to pay me $572.90 per month. $572.90 per month. Budget for that. Just a little bit over time, it's going to pay down your loans. Now the first month you're going to have some compound interest and it's going to build up, but you're going to pay that interest and then some of the principal. Now the total amount that you end up paying, we've seen this before, that deposit amount times the number of payments annually times the number of years, you will end up paying me $206,244. That's the interest. So the principal, the amount that you borrowed was $120,000. You end up not paying the $400,000 up above. You end up paying $206,000, giving us the amount of interest that we paid, $86,244. That's the amount beyond the principal that you end up paying. Now the idea here is that rather than paying all at once, waiting 30 years, you pay off a little bit at a time. So we've got this idea called an amortized loan. And an amortized loan is the way your student loans work, your mortgage payment, your car payment, your credit card. Anytime you borrow money and pay it back at a regular interval, that's called an amortized loan. Now the way it works is a lender, me, loans a borrower, you, a lump sum of money. So I'm going to loan you $120,000. You, the borrower, pays me back by making equal payments at a regular interval for a given period of time. So you are going to pay me back every single month for 30 years. That payment covers the interest accrued each month along the way during each interval, along with principal reduction. So you can look up something called an amortization schedule or an amortization table. And if you're going into finance or thinking about banking of any sort, you will get into this. This is important because someday you will have a credit card. Someday you will have student loans maybe, a mortgage, a car payment. This formula is how you pay money to other people. Now what we're going to do is we combined compound interest and the systematic savings formula. Essentially, I'm here on the left. I want my money to grow with compound interest. So I loan you $120,000. It builds compound interest. You are working the systematic savings formula to not pay the full amount 30 years from now or whatever the time period is. So what I'm going to do is I'm going to take this equation and we're going to rework it a little bit, simplify it, combine like terms. So we're coming up with what's called the amortized loan formula. Getting rid of the F there in the middle. I'm going to take this, I'm going to rewrite solving for P. Now P is multiplied by the 1 plus R over N raised to the NT, so we're going to divide by that. Now we notice over on the right side, we've got 1 plus R over N to the NT over 1 plus R over N to the NT. We're going to distribute this into both of those pieces in the numerator. That divided by itself would be 1, that divided by that. We come up with this formula. Now notice in the formula, my exponent here is negative NT. I'm going to change one more piece of this. Rather than D, I'm going to use the letter R for repayment amount. So we have what's called the amortized loan formula. We've got the principal is the rate, the payment amount, the repayment amount, 1 minus 1 plus the interest rate r divided by the number of annual payments. In the exponents, we have negative nt all over r over n. And there we have the different pieces. We've got the principal amount, your regular repayment amount, your interest rate, the number of annual payments, the time in years. This is the formula that drives your mortgage, that drives your car payment, that drives your credit card, your student loans. Let's take a look at this in our context. So here, college senior does not have enough money to cover expenses and plans to get extra money through a student loan. Now, there's three different things that we can find along the way. We can find P, we can solve for R, or we can solve for T. Today, I'm going to look at finding P and finding R. So here, we need to take out a student loan, reading for information along the way. Our student loan, we need some extra money. We can make quarterly payments. That tells me that N is 4. We're going to be doing this. We can take out a loan for 6 years. Our T, our time, is 6. Figuring out our budget, we're going to be able to make quarterly payments of $360. So we are going to solve for P, we know R. This is how much we are going to pay every 3 months, each quarter. We have an interest rate of 7% compounded quarterly. How much can we afford to borrow? So this is the idea saying that this is what's in my budget. This is what I can go out and take. Not, I want to go to this school, or not, I want that house. Oh no, I need to pay for it. It's, this is what's in my budget. This is how much I can afford. So we've gone through, identified the different pieces that we need for our formula. We're going to take our formula, substitute the values in. Now we're trying to solve for P. How much principal can we afford to borrow? So I'm going to take my values that we drew from the information above, substitute them into the formula. Now here, it's just a matter of all the numbers are on the right side of the equation. We're solving for P. I can substitute those into the calculator. Now, in my formula here, I've used these square brackets. Square brackets, not a thing in the calculator. That's just normal parentheses. So I'm going to go over to the calculator. Be careful to use my grouping symbols appropriately. There's my entire numerator divided by the entire denominator. All right. So making quarterly payments of $360, we can at most afford a $7,005 loan. Now, one other thing with this, we are paying $360 a month. Our principal is $7,005.85. Well, how much do we actually pay? The total payments is going to be the amount that we pay per period, the number of periods, and the total number of years. We've got $360 each quarter, 4 quarters in a year, 6 years. We pay a total of $8,640. That means the interest, the difference there, we end up paying $1,634 in interest. That's the amount that the bank makes based upon loaning the money to you. This is how banks make their money. This is how loans pay off things. So we can go through, we can solve for P. Let's take another example. Let's find R. We want to purchase a car. And seeing that the added charges for taxes, title, license fees, everything else that they don't tell you about, our car comes to $16,000 with some change. We need to make a 10% down payment on our vehicle, meaning we're going to take this principal, subtract 10% off this. We're going to pay the remainder through a car loan at an interest rate of 7.9%. All right, there's our rate, compounded monthly. We're going to repay this with monthly payments for 4 years. So I've gone through, identified the different components that we have for our formula. Now, we are going to take 10% off. So we're going to make a 10% payment up front. So the principal is actually going to be 90% of the initial sticker price. There's the value that we're going to use. We've got principal that we're going to use for the loan formula. We're going to solve for R. 7.9% interest. We're going to convert that to a decimal. Monthly payments for 4 years. So we've got our formula. We're going to substitute everything into our formula. And now we need to solve for r. Now we see that there's r is multiplied by the portion that's in the numerator. We are dividing by the portion in the denominator. So I'm going to cross multiply and divide. Solving for r. I can take that over to the calculator. Be careful with my grouping symbols. Now there's no square brackets. I'm just using those to say that those two go together. In the calculator, I will use the normal parentheses. Entire denominator. Uh-oh. That's not right. Oops. I put in way too much up front. 1.04-Introduction. All right, there we go. So we come up with R, it's 351.58. That tells us for this car loan, you are going to pay $351.58 each month. So if you've ever gone and taken out a car loan, this formula is how they figure that out. What you can do is you can go in when you're making a purchase on a credit or on a loan, you can figure out what's going to be your monthly payment, what's your total, how long is it going to take. It all is this formula. Your student loans, this formula. So thinking one more step, total payments on a loan, we are doing $351.58 every month for 4 years. We pay a total of $16,875 on the loan. The principal of the loan was that $14,429 after we already paid the 10%. So the interest that we end up paying is the difference. We pay $24.46 in interest. That is the amount beyond the principal. So putting everything back together, we have what we call our amortized loan formula. This is any time we have a loan, when you borrow money. It's your mortgage, your car payment, your student loans, your credit card. It all comes down to this. So we're going to play around with this a little bit. Try it out. Let me know what we got. Good luck. Catch you later.